We now proceed with the first chapter, all about counting rules. Alright, so we have the fundamental principle of counting. Yeah? So this is the first topic under chapter 1. The second topic under chapter 1 will all about permutation. And lastly, combination. Okay, so the objectives are as follows: count correctly the total number of possibilities in the arrangement of things or objects given certain conditions. Second, distinguish the difference between permutations and combinations. Next, establish a link between fundamental principle of counting and permutations. So, as we end the chapter, so I'm expecting that you will have this will be satisfied in your end. Okay, so in your end or in your part, this should be manifested. Okay, so we begin with the first topic, fundamental principle of counting. All right, so considering two operations, if an operation can be performed in n sub 1 ways and another operation can be performed in n sub 2 ways, the total number of ways the two operations can be performed is given by this formula. So total number of ways is equals to the product n1 times n2. So n sub 1 times n sub 2. So this is the fundamental principle of counting considering two operations. And the first operation, as mentioned, can be performed in n sub 1 ways. The second operation can be performed in n sub 2 ways. So the total number of ways now that the two operations can be performed no, is given by this formula. No? N sub 1 times n sub 2. So later I will show you an example with regard to this topic so that you can able to appreciate such discussion. Considering more than two operations, if we have more than two operations now, and we have the first operation that can be performed in n sub 1 ways, okay, in n sub 1 ways, then the second operation can be performed in n sub 2 ways, and the kth operation can be performed in n sub k ways. So the total number of ways the k operations can be performed is given by the formula. So you just multiply. Okay. So operation 1 can be performed in n1 ways, operation 2 in n2 ways, and so forth until we reach n sub k, until we reach operation k that can be performed in n sub k ways. Okay, so we simply multiply, no? So we get the product. Okay, so let me illustrate the formula with an example. Here's the problem. If in climbing a certain mountain, there are 5 trails that can be followed in going to the top and 4 trails in going down, in how many ways can the trip be done? Alright, let us consider this problem. So, we are to climb a certain mountain. So, there are 5 trails that can be followed in going to the top. Okay? So, if there are 5 trails that can be followed in going to the top, okay? So, what is operation 1? operation 1 is going to the top via trail. Okay, so that's operation 1. How many ways can it be performed? Okay, going to the top via trail. Okay, there are 5 trails that can be followed in going to the top. In other words, all the possibilities is equals to 5. It can be performed in 5 ways. Operation 1. So we have trail A. So all the possibilities going to the top of a mountain. So trail 1, trail 2, trail 3, trail 4, and trail 5. I can choose any of the 5 trails, right? So operation 1 can now be performed in 5 ways because there are 5 possibilities. No? How about in going down? Going down the mountain. Okay. So in going down, then 4 trails in going down. So that is operation number 2. Okay. Going to down through a trail or via trail. No? Going down from the mountain. So as mentioned in the problem, there are 4 trails. So we have trail A, trail B, trail C, and trail D. Okay? In how many ways can the trip be done? So so there are four ways in performing operation number 2, right? Operation number 2 is going down via trail. So there are 4 trails. So there are 4 possibilities. Okay? So I can choose any of the 4 trails. Therefore, since I have 4 options, there are 4 ways in performing operation 2 because I have 4 options. In going to the top, I have 5 options, meaning there are 5 ways in going to the top of the mountain. So there are 4 ways in performing operation 2, going down the mountain. So now the problem is, how will we determine the number of ways, no, that the trip can be done? Alright, to illustrate, so I have, let's say, going to the top, I chose trail A, trail 1. Okay, I chose trail 1 going to the top. Okay, so going to the top, I chose trail 1, and going down the mountain, going down from the mountain, I chose trail A. So that is one count. Okay, or another count, trail 1 to trail B. Okay, so another one plus 1. Then trail A, trail 1 to trail C, plus 1 again. Trail 1 to trail D, plus 1 again. Okay, so plus trail 2 to trail A. Okay, plus 1. Okay, plus trail 2 to trail B. Okay, so this is the common way of determining the number of possibilities, right? It's the conventional way. Later, I'll teach you the shortcut way. Okay, so then now we have trail 3 to trail A, another one. Okay, plus trail 3 to trail B, trail 3 to trail C, trail 3 to trail D. Okay, next, trail 4 to trail A, trail 4 to trail B, trail 4 to trail C. Okay, and trail 4 to trail D. Next, trail 5 to trail A, okay, trail 5 to trail B, trail 5 to trail C, and trail 5 to trail D. And if we will sum all of those, 20, right? 4, 8, 12, 16, 20. Okay, long approach. But is there a short approach? Yes, there is. Using the fundamental principle of counting rule. Okay, as stated in the fundamental principle of counting rule, if operation 1 can be performed in n1 ways, the second operation can be performed in n2 ways, the total number of ways that operation 1 and operation 2 can be performed together is equals to the product of the number of ways per operation, n1 times n2. So 5 times 4, that is 20. There, we don't need to do this. Okay, so this is more convenient to do. It will save time. Okay, so we got 20. Okay, simply multiplying the two number of ways. Okay, all right, so we're done with this. No, I hope you get it. So 20. So problem 2. A burger machine offers a serving of soup, sandwich, and beverage. There are two kinds of soups, corn or asparagus, four sandwiches, chicken, ham, mushroom, or tuna, and five beverages, coffee, tea, milk, coke, or orange, to choose from. Then the number of possible combinations is what? So there are two kinds of soups. So that is operation 1. For operation 1, since there are two kinds of soup, it can be performed in two ways because I have two options. I can either choose corn or asparagus. Okay? So N1, choosing a soup. I have There are two ways to perform operation 1. Because I have two options. I can either choose corn or asparagus. Operation 2, choosing a sandwich. I have four sandwiches. Chicken sandwich, ham sandwich, mushroom sandwich, or tuna sandwich. Okay? So that is now equal to 4. Okay? Then that is for operation 2. Now selecting a beverage. What beverage do I prefer? Is it coffee, tea, milk, coke, or orange? I can only choose one. So, since there are five options and 3 equals to 5, there are five beverages to choose from. Therefore, operation 3 can be performed in 5 ways. So then the number of possible combinations is what? Since we have three operations here, recall the formula for the fundamental principle of counting. Okay, the number of ways for more than two operations. So the first operation can be performed in n1 ways. We just multiply it by the second number of ways. The second operation can be performed in n2 ways, and so forth until reaching the last operation. In here, last operation is 3. So k is 3. Okay? The kth operation, which is the third operation, can be performed in 5 ways. So in that case, this will now be reduced to n1 times n2 times n3, giving us 2 times 4 times 5. And we got 40. Let's see. 40. There. 40 possible combinations. Okay? So, first, 1 out of 40, corn, chicken, coffee, that's one count. Next, corn, ham, coffee, another count. Then corn, mushroom, coffee, third. Corn, tuna, coffee, fourth. Okay. Then corn, chicken, tea, fifth. Corn, ham, tea, sixth, and so forth until we reach the 40th, which is asparagus, tuna, and orange. Okay, that's it. No? So this is the shortcut. No? Using the fundamental principle of counting rule. Okay, third problem. In a medical study, patients are classified in 8 ways according to whether they have blood type AB positive, AB negative, A positive, A negative, B positive, B negative, O positive, O negative, and also according to whether their blood pressure is low, minimal, and high. In how many ways can a patient be classified? Okay, so this is in a medical study, patients are classified in 8 ways according to whether they have blood type. So in other words, operation 1 is okay, blood type of a person, and there are 8 possibilities for the blood type of a person, and it can now be performed. Operation 1 can be performed in 8 ways. Okay, and also blood pressure. Operation 2 has something to do with the blood pressure. Okay, blood pressure condition of a person. Blood pressure condition of a person. So the blood pressure condition of a person can be low, can be minimal, and can be high, or can be high. So in that case, I have three options. So therefore, operation 2 can be performed in 3 ways. So in how many ways can a patient be classified? So 24, simply as that. Now, 8 times 3, we get 24. So I hope you get it. Next, problem 4. In a class of 20, the number of ways of selecting a president, vice president, secretary, and treasurer is what? Okay, so in a class of 20, so given. So there are 20 students in the class. So what is operation 1? Operation 1, selection. Selection of a president. So in selecting a president, what are the total number of possibilities? 20. There are 20 is the total number of possibility, no? So in that case, N1 is 20. Okay? Operation 1 can be performed in 20 ways. Since there are 20 students in the class, they have all the potential to be the class president. How about operation number 2? Selection of a vice president. Okay? Selection of a vice president. Since a president was already chosen in performing operation 2, what will be the number? So 1 already became the president. Therefore, there are 19 left that has the chance to be the vice president. Therefore, operation 2 can be performed in 19 ways. Now, selection of a secretary. Since there are already two positions occupied, president and vice president, therefore, in performing operation 3, that will be 18 ways. Selection of a secretary. And then 17 for the treasurer. Okay? So 3, so 20 minus 3, 17 for the treasurer. For considering the fourth operation, selection of a treasurer. And what is the total number of possibility? So the total number of ways of selecting a president, vice president, secretary, and treasurer is equals to N1 times N2 times N3 times N4. And that is 1,116,280. 20 times 19 times 18 times 7. Okay? So kung magmamano-mano ka magbibilang, baka umabot ka ng bukas na aabot ka sa 116 to 80. So, kaya na-develop itong fundamental principle of counting rule as a guide para hindi tayo mahirapan magbilang na ng lahat ng possibility. So, that's it. No? So, problem 5. A test is composed of 10 multiple choice questions, with each having 4 possible answers. In how many ways can a student answer all the questions? Alright, so we have a multiple choice exam, 10 items. And for every item, there are 4 possible answers. Let's say item number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So A, B, C, D, for example. Okay, so and so forth. Okay, A, B, C, D. So a test is composed of 10 multiple choice questions, with each having four possible answers, either A, B, C, or D. For example, in how many ways can a student answer all the questions? So, the first way, a student answered from 1 to 10 all A, no? Lahat ay A. That is one count. Pwedeng 1 to 9, tapos number 10, B. Another count. 1 to 9, A lahat. Number 10, C. Another count. Hanggang umabot sa lahat ay D. 1 to 10. O, ano yung total number of possibilities? Okay, hindi tayo matatapos siguro kung ma-manual natin yan, no? So, kailangan natin ng fundamental principle of counting rule para mapadali yung ating solution, yung ating problema, no? Mapadali yung para hindi tayo mahirapan, no? A test is composed of 10 multiple choice questions with each having four possible answers. In how many ways can a student answer all the questions? Operation 1. Operation 1 can be performed in four ways. Kasi, I can choose A, I can choose B, I can choose C, I can choose D. So, four ways. So, this is 4. Operation 2, ganun din. I can choose any of the four options. Okay? So, hanggang umabot sa pang-last. I can choose any of the four options. Okay? Operation number 10. Selection of an answer. Okay? Siyempre, sa problem, meron lang isang possible answer. Okay? Meron lang isang correct answer. Pero merong apat na possible answers. So, therefore, four ways of performing operation number 10. Okay? So, lahat sila ay 4. Therefore, solution. Number of ways, n1 times n2 hanggang umabot ka ng pang-10. Okay? So, first operation, second operation until the 8th operation, the 10th operation, no, the last operation. So, ibig sabihin niyan, i-multiply mo yung 4 ng 10 beses sa sarili niya. 4 times 4 times 4 times 4 hanggang umabot ng 10. 10 beses. Then, that will give us an answer of, so ano ang 4 raised to 10? Diba, laws of exponents, 4 times 4, 4 squared. 4 times 4 times 4, 4 cubed. So 4 to the 10th power. What is 4 to the 10th power? And that will give us 1,048,576. So there are 1,048,576 ways, no, in answering the 10 questions. Okay? Pwedeng 1 lahat, A lahat hanggang 1 to 10, A lahat, 1 count. A lahat, 1 to 9, tapos number 10, B, another count, hanggang sa umabot ka sa huli na D lahat. So, yun yung pang 1,048,576. No? Okay. So, that's it. I hope you get it, no? Okay, problem 6. How many numbers of 5 different digits each can be made from the digits 1, 2, 3, and up to 9 if the numbers must be odd, and B, the number must be even. Assume numbers are non-repeating. Okay, so how will we solve the problem here? So given from the digits 1 to 9, 4 digits are even and 5 digits are odd. Okay. Okay, from the digits 1 to 9, 4 digits are even and 5 digits are odd, right? Ano yung mga ating even numbers and odd numbers? Even numbers are as follows: 2, 4, 6, and 8 from the digits 1 to 9, right? And what are the odd numbers? 1, 3, 5, 7, 9. So, from the digits 1 to 9, 4 digits are even. 2, 4, 6, 8. So, 4. Okay, 4 digits. 2, 4, 6, 8. So, apat. 5 digits are odd. 1, 3, 5, 7, 9. So, 5 yan. Okay. How many numbers of 5 different digits? Ayan. How many numbers of 5 different digits each can be made from the digits 1 to 9 if the number must be odd? So, ibig sabihin niyan, bubuo ka ng isang 5-digit number na kung saan iba-iba. Iba-iba na number. Unique lahat ng mga digits. Okay? Sa bawat place. Meron kang units place, tens place, hundreds place, thousands place, 10,000s place. O, iba-iba ng digit sa bawat place. And the problem here is paano natin malalaman yung total number of possibilities na kung saan the number must be odd. So, para maging odd, kailangan ang ending number ay odd para yung buong number ay maging odd. Sabihin yung last digit, dapat odd number para masabi natin na odd number yung 5-digit number. Example, 1,000 to 12,345. 5-digit number yan. Nag-e-end sa 5 which is odd. Therefore, yung buo, dahil odd ang huli, odd na yan. Right? So that is an odd number, 12,345, because the last digit is 5, which is an odd number. Okay? So, kung ganon, anong solution sa problem ngayon natin? Setting solution. Okay. Meron tayong units place, tens place, hundred place, thousands place, 10,000s place. Okay, umpisa natin sa units place. Sabi sa problem, the number must be odd. Therefore, BR operation 1. Operation 1, selection of a digit, okay, to be placed at U. Ito. To be placed at U. Selection of a digit to be placed at U. Yung units place, no? Yung sa hulihan na number. Okay. How many ways can it be performed? Operation 1. Since in the problem, letter A, the number must be odd. And if it is odd, this could only be any of the 5 digits. It could be 1, 3, 5, 7, and 9. Nothing more and nothing less. 1, 3, 5, 7, and 9. So therefore, there are 5 possibilities. There are 5 ways now to perform operation 1. Selection of a digit to be placed at the units place. Because I can choose any of the 5. So I have 5. Next, is there any restriction? Is there any restriction? The rest of the digits in this 5-digit number, is there any restriction? None. only the last digit is restricted, right? So it can we can only allow an odd number to be placed at the units digit because we have to satisfy the condition the number must be odd for letter A. In that regard, we now consider operation 2. For operation 2, selection of a digit from 1 to 9 to be placed at the 10,000th place. So, since a number is already selected at the units place, no? Let's say any number, 1, 3, 5, 7, and 9. A number is already selected. Therefore, how many ways can we perform operation 2, selection of a digit to be placed at the 10,000th place? There are 9 numbers, right? Digits from 1 to 9. And at the units place, we already place a number. Can we repeat the number at the 10,000th place? Let's say if what is placed at the units place is 1, can we still put 1 here? The answer is no, because there's a restriction. 5 different digits. Okay? Therefore, the number that was placed at the units place must not be the same as that of the 10,000th place. I hope you get it now. So in that case, since 5 was since there is already a digit placed at the units place, and so that we have 5 as the total number of possibility, no? 5 ways in performing operation 1. Therefore, we have only 8 options left. We have only 8 options left because there are 9 digits and 1 is already placed at the units place. Therefore, there will now be 8 options. In other words, any number except any number 1 to 9 except the one placed at U. So, therefore, any number 1 to 9 except the one placed at U. So, therefore, 8. 8 possibilities, right? Operation 2 can be performed in 8 ways. Next, selection of a digit to be placed in the thousands place. Okay, so again, I cannot repeat the digits placed at the units place and 10,000s place because there's a restriction that the digits must be different for this 5-digit number. Since 2 are already occupied, the units place and the 10,000s place, there are only 7 options left. So, yung dalawa, nagkaroon na ng number. Ngayon, kung 9 lahat ng number, ilan ng possibility dito sa thousands? 7. 9 minus 1 minus 1. 9 minus 2 yon, 7. Sabihin niyan, any number 1 to 9, any number 1 to 9 except the one place at U and TTH. and TTH. So, sabihin niya, yung dalawa. So, any number 1 to 9 except yung nilagay natin sa U at saka itong sa TTH. So, in that case, we now move at the hundreds place. 7 na yan. So, 3 are occupied. So, 6 na lang. Tens naman, 4 are occupied. 5 na lang. Okay? So, nabawasan. No? 8, 7, 6, 5, 5. No? And i-multiply lahat natin yun. Yun ang sagot. So, again, 5, 8, 7, 6, 5, 5. Ayan. Okay, I hope you're not confused. No? And the answer is 8,400. So, there are 8,400 5-digit numbers wherein all digits are different and all numbers are odd. No? So, itong 8,400, different digits lahat. At the same time, odd number pa siya. 8,400 numbers na 5 digits. No? So, that's it. No? For letter B, the number must be even. Okay? Assume numbers are non-repeating. So, that's the assumption. So, for letter B, the number must be even. So, in other words, we are only allowed to place a number at the last digit to be an even number. If the last digit is an even number, we can say that the 5-digit number will also be an even number because the last digit is an even number. Okay? So that's the restriction imposed. And to satisfy that, we have to determine all the possibilities for the last digit. So it is possible that from the digits 1 to 9, it can be 2, it can be 4, it can be 6, it can be 8. So these are the possibilities, right? 2, 4, 6, 8. And all are even. So operation number 1, selecting an even number to be placed at the units place. So we are to select an even number. And we have 4 options. We can choose 2, we can choose 4, we can choose 6, we can choose 8. Therefore, this will be 4. Because for operation 1, it can be performed in 4 ways because we can select any of the 4 digits, 2, 4, 6, 8. Next, we shall identify now the number of possibilities for placing a number in the first digit, the 10,000s place. What are all the possibilities? If we consider the problem, assume numbers are non-repeating. So, in other words, if we already place a number at the last digit, we cannot repeat that at the 10,000s place. So, if we have numbers 1 to 9 and we already place a number at the last digit, how many are left? If these are 1 to 9, so there are 9 numbers, and we already placed a number at the last digit, therefore, there we have only 8 options left. Next, after obtaining the number of possibilities for the 10,000s place, no? So after obtaining the number of possibilities at the 10,000s place, we are to select now a digit to be placed at the thousands place. So Again, numbers are non-repeating. We cannot repeat the number that was placed at the units place and the 10,000s place. So if there are nine digits all in all, we subtract 2 from it, from the total number of digits, we will now get 7. So this will now be 7. Afterwards, we are to select the number of ways of performing operation number 4. Operation number 4 is selecting a digit to be placed at the hundreds place from the digits 1 to 9 such that the numbers are non-repeating. Since there are 9 numbers, 3 are already occupied, 6 are left now. So this will become 6. Then the pattern continues. There are already 4 slots occupied, and we have one more slot left to be occupied by a digit that comes from the digits 1 to 9 such that there are no repetitions of digit. So we have total number of digits 9 minus the 4 occupied ones. 9 minus 4, we get 5. So that's it. I hope you get it. And we will obtain an answer of 6,720. So there are 6,720 5-digit numbers that are even. Okay? So there are 6,720 numbers that are even. To give you an example, from the digits 1 to 9, 12,346. This is even. So this can be 1, 2, 3, 4, 6. Okay? This is the 5-digit number and it is an even number, satisfying the condition the number must be even. Since the last digit is 6, it is considered even. We can also have 12,348 even. Okay? And until we reach 98,764, no? 98,764. This is the last even number. So this is the first among 6,720 numbers. This is the second, and this is the 6,720th number that can be obtained from the digits 1 to 9. It's so many, right? So they all in all 6,720. Okay, so I hope you get it. So we can proceed now. So here's problem 7. In how many ways can 5 boys and 3 girls be seated in a row of 8 seats if the ends are to be occupied by boys? So let's analyze. Upon occupying the first and 8th seat by the 2 boys from the 5 boys, there will be 6 seats left to be occupied by the remaining 6 persons, regardless of sex. So, in other words, since our goal is to place a boy in the first seat and the last seat, and the rest between the 2 boys, any gender or any sex can be male or female. Okay, so that's the condition. So the first seat and the 8th seat now are to be occupied by boys from the 5 boys. So it can be boy number 1, boy number 2, It can also be boy number 2, boy number 1 there, boy number 5, boy number 4, okay, and so forth. No? So let's see. So let's occupy first the first or the last. We can start at the first or at the last. No? So first question, how many boys do we have all in all? We have 5. Now, therefore, we start with the first set. Since there are 5 boys all in all, and we are to perform operation number 1, selection of a boy, no, to be placed at the first seat. So since we have 5 options, therefore there are 5 ways of performing operation number 1. The next step um, is to place a boy at the 8th seat. Since there is already a boy that was seated at the first seat, we can now consider the remaining boys, which are 4. There are 4 left, 4 boys left. No, any of the 4 boys can sit at the last seat, at the 8th seat. So therefore, we have 4. That's operation number 2. We have 4 ways of performing operation number 2. Now, the second set, there are no restrictions imposed. We can select any sex, either male or female, either boy or girl. So therefore, we consider the totality of the people regardless of sex. So we have here 5 boys and 3 girls. We have 8 people. And from the 8 people, there are already occupied slots, the 2 slots, the first and the eighth. The first and the eighth seat were already occupied. Therefore, there are 6 people left waiting. No, uh, there are 6 people left that can occupy any of the 6 seats. No, the second and the seventh seat. No, any of the 6 seats. So the 6 people, we start with the second seat. Since there are 6 people left for performing operation number 3, selection of a person to be placed at the second seat. Since there are 6 people left, that will now be 6. Okay? Because we disregard sex. Any gender can occupy this slot, this second seat. Next, the third seat is to be occupied by any gender. Therefore, there are 5 people remaining now because 3 are already occupied. Therefore, this will be 5. Okay? And the pattern continues. 4, 3, 2, 1, and so forth. Okay? 5, 4, 3, 2, 1. Oh, we will end up with 1. That's the termination. So, we will now have an answer of 14,000 per 100 ways. So, there are 14,000 per 100 ways of uh, arrangements for the 8 people such that the first and the last seat must be a boy that will sit. Okay? The first and the last seat must be occupied by boys. Okay? So 14,400 ways. I hope you get it. So we proceed. Here's problem A. How many three-digit number can be performed from the four digits 0, 1, 2, and 3 if letter A, no two digits are to be the same, B, no two digits are to be the same and the numbers are odd, C, no two digits are to be the same and the numbers are even, D, repetition of numbers allowed. Alright, let's analyze. So we are to determine the number of three-digit number now that can be formed from the four digits 0, 1, 2, and 3. So there is a restriction imposed that no two digits are to be the same. So considering no repetition of digits in the three-digit number for A, B, and C. So this is considered now for A, B, and C. Because for letter D, repetition of numbers allowed. Okay. So considering letter A. So here's the three-digit number. So what are all the number of possibilities for here for forming a three-digit number such that no two digits are to be the same? So meaning all digits must be different. So let's start at the first uh, place, hundreds place. So this is 3. Why 3? What are the possibilities? Can we place 0 at the hundreds place? Definitely not. Because if we place 0, 0, 1, 2, for example, is not a three-digit number. Instead, it is a two-digit number. This will be disregarded. So therefore, the hundreds place now can never be 0 for us to conclude that it is a three-digit number. No? So, in other words, the hundreds place must not be occupied by 0 because it will not be a three-digit number in short. No. Therefore, we can only place 1, 2, and 3 at the hundreds place. So there are all three possibilities. It can be 1, it can be 2, it can be 3. Okay? Next, placing a digit at the tens place. Now, since the hundreds place is already occupied and we cannot repeat what we place at the hundreds place because there's restriction imposed that no two digits are to be the same. So therefore, if these are 4 and 1 is already occupied, no? So there are 3 left. 3 left, no? So because 1 was already occupied. Okay? So 4 minus 1 that was placed here, we have 3. So this will become 3. Okay? And then for the last digit, there are already 2 numbers placed at the hundreds and the tens place respectively. And there are now 4 minus 2. 4 minus 2, so there will now be 2 left. No? 2 left that we can place at the units place. So we have 2. So therefore, the answer is 18. Okay? So letter B. No two digits are to be the same and the numbers are odd. So again, no repetition of digits and the numbers are odd. So considering the three-digit number, if the numbers are odd, therefore, this can be from the digits 0, 1, 2, and 3, we are only allowed to use either 1 or 3, because 0 is an even number, 2 is also an even number, and 1 is an odd number, 3 is an odd number. Therefore, there are two ways. No? That's operation number 1. Selection of a number to be placed at the units place. So, there are two ways. We can either choose 1 or 3, right? Next, hundreds place. So, for the hundreds place, there are 4 digits, and 1 is already occupied. Okay? There are 4 digits and 1 is already occupied. How many will be left? Is it 3? Analyze carefully. Let's say, so we have selected a digit, right? Let's say we consider 1. Let's say 1 was selected. So there are 3 left, 0, 2, and 3. But we cannot choose 0 to be placed at the hundreds place. Therefore, we have now two options left, either 2 or 3. We have two options, right? If I selected 3, if 3 was placed at the units place, and I will now place a number at the hundreds place, I have 3 numbers left, 0, 1, and 2, but the hundreds digit cannot be 0. Therefore, I have two options left. So regardless if I select 1 or 3, still this will be consistent. This will be two options. Okay? So, in other words, this cannot be 0. At the same time, this is already occupied. So, 4, total digits 4, minus 1 because it cannot be 0, minus 1 because it cannot be repeated what was placed, no, at the hundreds place, no. So hindi siya pwedeng ulitin. So therefore, kasi no repetition, there are 2 left. Okay, there. Now, for the tens place, any number can be selected. Hindi maselan. Any number can be selected. However, there are already occupied numbers at the hundreds and the units place. Therefore, since there are no repetition of digits allowed, so 4 minus 2, 2. So that is become 2. So the answer is 8. Okay, there. Next, letter C. No two digits are to be the same, and the numbers are even. So this time the numbers are even. No two digits are to be the same, and the numbers are even. So for letter C, the number of three-digit even numbers that can be formed if no two digits are to be the same is equal to the number of three-digit numbers that can be formed if no two digits are to be the same. So ito siya, 18. Minus number of three-digit odd numbers that can be formed if no two digits are to be the same. So that is 8. At in total, 18 numbers. Pinagsamang odd and even na yan. Ito, puro odd. Puro odd. 8 odd numbers. Therefore, pag minus natin yung 18, pag minus natin yung 8 from 18, matitira ay 10 at automatic this will be even. So therefore, 10 will be the answer. Okay? Okay, so before I proceed with letter D, so before I proceed with letter D, so there's an alternative solution to that problem. No, for letter C. Okay? So gayahin natin yung style na ganito. Okay? Maglalagay tayo ng HTU. So, alright. So, not two digits are to be the same and the numbers are even. Okay? So, from the digits 0, 1, and 3. So, from here, we can select 0 or 2. This can be 0 or 2, right? Here, this cannot be 0. This can be 1, 2, and 3. Here, any number, 0, 1, 2, and 3, right? This can be 0 or 2. This can be 1, 2, and 3. This can be any number from 0, 1, 2, and 3. So if we begin at the units place, uh, we we have two options, 0 or 2. Then if we proceed with the hundreds place, uh, if 0 was selected at the units place, we have three options. 0 was selected at the units place, we have three options, 1, 2, or 3. If 2 was selected at the units place, so we cannot place 2. Therefore, there will be two options. It's not consistent. It's not consistent unlike here. Here, this is odd. We can place 1 or 3. Here, we can place 1, 2, and 3. If we place 1 at the units place, we have two options, 2 or 3. So that's 2. If we place 3 at the units place, we still have two options. We can no longer place 3, 1, and 2. So we still have 2. So it's consistent here, no? However, considering this situation, if we place 0, we have three options, 1, 2, or 3 for the hundreds place. If we have placed 2 at the units place, we cannot use 2 anymore. So we have two options, either 1 or 3 to be placed at the hundreds place. So how can we settle the problem now? How can we solve this? Alright, so to solve the problem, since there is inconsistency, so we consider the two situations. So we are to separate. We are to separate the two. Because there is inconsistency, we must separate. In other words, for the condition, no two digits are to be the same and the numbers are even. So this is even. This must be even and we will choose 1. We will choose 0 for instance. 0 was considered. This is even. And 2 was considered. No? 2 is considered here. 0 is considered here. Okay? From the digits 0, 1, 2, and 3. So 0, 1, 2, and 3. 0, okay, for this at the left part, 2 at the right part, no? So therefore, if this is only 0, that's only one option. If this is 2 only, that is only one option. We can only place 2. Okay? If that was considered, since this is 0, okay, 0 was selected here, so 0 is selected, and 0 cannot be placed at the hundreds. Therefore, it will be 3, right? We have 3 options. We can choose 1, 2, and 3. 1, 2, or 3. And then, for the tens place, we cannot repeat the digits that was placed at the hundreds and the units place. Therefore, 4 minus the 2, 4 minus 2, that will be 2. Next, we consider the right term, okay, for HTU. Even to 1, so that is one option. We will select 2. For the hundreds place, since 2 was selected, we cannot place 2 here anymore. Also, we cannot place 0. That's automatic. We only have 2 options, 1 or 3. We can only select 1 or 3. So we have 2 options. For the tens place, there are no restrictions imposed here except that they must not be repeated. No, the digits must not be alike to the digits placed in the hundreds place and the units place. So this will become also 2. This will also be 2. Because 4 total minus 2 occupied, that will be now 2. So adding the 2, 3 times 2, 6, plus 2 times 2 times 1, 3 times 2 times 1 is 6, 2 times 2 times 1 is 4, the sum is 10. There, we got 10. Similar to this process, 18 minus 8 equals to 10. I hope you get it, no? For letter D, repetition of numbers allowed. So for the hundreds place, we cannot select 0, so we have 3 options. For the tens place, we can select any of the 4 digits, 0, 1, 2, and 3, so 4. In other words, we can repeat the digit, no, that was placed in the hundreds place. No? Let's say ang nalagay ay 1 o nalagay diyan ay 1. So pwede pa rin maging 1 kaya 4 na option pa rin 'yan. No? So for the units place, 4 na option pa rin. Okay, pwedeng mag-repeat. No, we can select 0, 1, 2, and 3. Okay? 3, 4, 4. Okay? So, and the answer will be 48. So, there are 48 numbers that are 3 digits, no, that were in repetition of numbers allowed. Okay? So, that will be 48. I hope you get it, so we can proceed. Problem 9. How many numbers with no repeated digit using 4, 5, 6, 7, 8 can be less than 520 and letter B greater than 5,000? So let's analyze. Solution to the problem. For letter A, considering no repetition of digits for any n-digit number less than 520. So, less than 520. So, consider we consider no repetition of digits. So, in this case, for a three-digit number, we have 143. Bakit siya 143? Okay. For 5, 6, 7, 8. Less than 520. Ano yung 5-digit number na pinakamababa dito? 546. Right? 4, 5, 6, 7, 8. Anong 5-digit number, anong 3-digit number pinakamababa? Such that nagumpisa sa 5. Sa hundreds place, 546. Therefore, ang 546 ba ay mababa sa 520? Hindi. So, therefore, hindi na allowed ang 5. Lalong hindi allowed ang 6 kasi sobrang taas na yan. Hindi rin 7, hindi rin 8. So, 1. 4 lang ang pwede. One option. One option. No? 4 lang ang pwede. Okay? O ngayon, sa tens place, 4, 5, 6, 7, 8. Kahit anong lin dyan, pwede. Pwede ito maging 4, pwede ito maging 5, 6, 7, 8. Pero, 1 is already occupied kasi no repetition of digits. 5 minus 1, 4 left. And then, yung sa units place, 5, wala ring bawal dyan na ilagay. Wala nang bawal dyan na ilagay. Ang meron lang bawal yung sa hundreds, no? So, 5 minus yung 2, 3. Okay. So, that's it. So, that is 12. That is only for a 3-digit number. Kasi, masasabi rin natin na ang 2-digit number less than 520. Right? Hindi lang 3-digit number. So, for a 2-digit number, kahit alin dyan sa 5, pwede. Pwedeng maging 4, 5, kasi ang pinaka mataas dyan ay 87. Pwede itong maging 87, which is less than 520. So, 4, 5, 6, 7, 8. So, I have 5 options. So, for yung sa units, dahil no repetition of digits. So, 5 minus yung 1 dito, so kaya 4. So, we get 20. Then, of course, pwede yung single digit number kasi less than 520. For a single digit number, automatic 5. 5 options. Kasi, ang 4, ang 5, 4 is less than 520, 5 is less than 520. So, ilan lahat yan? 5. Yung 5 numbers na yan, 4, 5, 6, 7, 8, less than 520. So, we have 5. No? And we will add them all. Numbers less than 520 with no repeated digit, 12 plus 20 plus 5, 37. So there are 37 digits all in all. Less than 520. How about greater than 5,000? So for a 4-digit number greater than 5,000, ito siya. Greater than 5,000, therefore hindi na pwede yung 4. Pwede yung 5. Ano pinaka mababang number dito na 4-digit na greater than 5,000? Yung 5 na yan, pag naumpisa ng 5, pinakamababa dyan. 5, 4, 6, 7, right? 5,467. Greater than 5,000 yan. So therefore, automatic 5 is considered. Of course, 6 will also be considered, 7 and 8. So we have 4 options. Okay, for for the thousands place. And then, sa hundreds, wala nang bawal. 5 minus 1, 4. Sa tens, walang bawal, except na hindi pwede mag-repeat, no? 5 minus 2, 3. Then sa units, 5 minus 3, 2. Okay, 4, 4, 3, 2, and we will get 96 para sa 4-digit number. How about 5-digit number? Sa 5-digit number, automatic, kahit alin dyan pwede. Kasi automatic ay greater than 5,000 pag 5-digit number. So, therefore, 10,000s place, pwedeng 4, pwedeng 5, pwedeng 6, pwedeng 7, pwedeng 8. So, I have 5 options. For the thousands place, no, because no repetition of digits, 4. For the hundreds, 3. For the tens, 2. For the units, 1. And we get 120. And our answer is 216. We just add 96 and 120.